Today we're going to be working on answering problems on trigonometric equation, and when we're solving problems involving trig equation, we're going to be needing our unit circle to find the values of x in a trig equation, and sometimes you can also use a complete set of trig values which you can download online, and these are basically the values of x or values of your trig function given special angles, and this is what we're going to be using in solving problems involving trig equations. So let's go ahead and start working on answering problem number 1. For problem number 1, we have 2 cosine x minus 1 equal to 0. And whenever we're solving trig equation, since we're not too familiar with working with trig equation, we can relate this equation into an algebraic equation. So if we're going to translate this equation to a similar algebraic equation, this is similar to 2x minus 1 equals 0. And solving an algebraic equation like this, we need to add 1 on both sides so that we have x by itself, and then divide both sides by 2 so that x is equal to 1/2. And the same principle applies in working with trig equation. So since x is equal to cosine x, we're going to be basically solving for cosine x in this equation. So 2 cosine x minus 1 equals 0. So solving for x or cosine x, we'll add 1 on both sides, and we'll have 2 cosine x equals 1, and we divide both sides by 2 so that we can have cosine x by itself, which is equal to 1/2. So they follow the same principle. It's just that for some students, or for some of you who are working on trig equation for the first time, it can be a little bit awkward to solve problems involving this type of equation. But if you can relate it to something that you're more familiar with, it's actually really simple. So this is the value of cosine x in our equation, but we are not finished yet, because after finding the value of cosine x, we're going to be using our table of values or the unit circle to find all the values of your cosine x equal to 1/2, so we can find the value of x, which is basically the angle in the unit circle. So in your table of values, so we're looking at cosine x equal to 1/2, so we have sine, cosine, tangent. So cosine x, find all the values of cosine that's equal to 1/2, and it will be pi over 3 and 5 pi over 3. So the value of our x is going to be x equal to pi over 3 and 5 pi over 3. So this is how we solve trig equation, by using our unit circle or the table of values. So let's go ahead and answer problem number 2. Go ahead and answer problem number 2, and for problem number 2, we're going to be looking for sine squared x minus 1 equal to 0. Now to solve this problem, we're going to have sine x by itself, so we will add 1 on both sides. And sine squared x in trigonometry can also be rewritten as sine x quantity squared equals 1. And to get rid of our exponent 2, we will take the square root of both sides. So we'll have sine x equals plus or minus square root of 1 is equal to 1. So we're going to look at the table of values again. And from the table of values, we're going to look for all the values of sine x that's equal to plus or minus 1, so that we'll be able to find the value of x. So in this case, sine x equal to plus or minus 1, we have pi over 2 and 3 pi over 2. So those are the only two values of sine x that's equal to positive or negative 1. So let's go ahead and write it down. Pi over 2 and 3 pi all over 2. And that's how we solve for problem number 2. And Let's continue on answering problem number 3. So we have 3 tangent squared x minus 1 equal to 0. So we will add 1 on both sides. So we'll have 3 tangent squared x equals 1. And we divide both sides by 3. So we have tangent squared x equal to 1/3. And by taking the square root of both sides, we'll be able to eliminate the exponent. So we have tangent equals plus or minus square root of 1/3, which we know is going to be square root of 1 is 1, and square root of 3 is a prime number, so we have square root of 3. But in trigonometry, we always rationalize our denominator. So to rationalize this, we multiply both sides by the square root of 3, or both the numerator and denominator. So we'll have square root of 3 all over 3. So now we're going to be looking for tangent x equal to plus or minus square root of 3 all over 3. So we can find the values of our x. And in our unit circle, looking at tangent, we need the plus or minus square root of 3 over 3. So we'll have 4 values of this in one rotation. So we'll have pi over 6. We have 5 pi over 6. 7 pi over 6. And 11 pi over 6. So these are the values of our function for problem number 3. We have pi over 6. 5 pi over 6. 7 pi over 6, and 11 pi all over 6. So in one full rotation of our solution set for a trig function, it could either be a 1 solution, no solution, we could have 2 solutions, and we could have as much as 4 solutions in one full rotation of a unit circle. So that's the maximum number of solutions that we'll have in one full rotation in our unit circle. Now let's answer problem number 4. And we have tangent 2x minus 1 equals 0. Now this one will be a little bit different from the other 3 problems because we have a coefficient on our variable x. So we're going to solve this out just like how we did, or how we solved the first 3 problems. So we add 1 on both sides and have tangent by itself. And since tangent is now by itself, but we have 2x, all we need to do is to find all the values of tangent x equal to 1, and we're going to be equating it to 2x. So the values of tangent x, so we'll just ignore the coefficient for a while and look for all the values of tangent x equal to 1. So this is our tangent value, and all the values of tangent that is equal to 1 would be pi over 4 and 5 pi over 4. So pi over 4 and 5 pi over 4. But since this is equal to 2x, we're going to get rid of 2 by multiplying both sides by 2. So we'll have x equal to pi all over 8 and 5 pi all over 8. So that is the difference between finding the values of our solution when we have a coefficient right next to our variable. So these are the 2 solution sets of our problem number 4. Now for problem number 5, we're doing inverses. So we have 2 secant x minus 4 equals 0. And most of the time, we're just given the values of our sine, cosine, and tangent. So later on, we're going to find the inverse function of secant, so we can use our table of values in our unit circle and in our table of values. So let's go ahead and solve for x for problem number 5. We add 4 on both sides. So we have 2 secant x equals 4. And then you divide both sides by 2. So secant x is equal to 2. Now, since most of the unit circle or table of values, it only gives you the sine, cosine, and tangent, we're going to transform our secant x equal to 2 into its inverse, which is cosine. So 1 over secant x is the same as 1 over 2. And the inverse of secant x is going to be cosine x. So now, secant x and cosine x 1/2, they are related. So we can use our table of values and look for cosine x equal to 1/2, so we can find our solution for this secant function. So for cosine x, so we have 1/2. So we have pi over 3 and 5 pi over 3. Now, since my table of values gives me its inverses, we can also see that at 1/2 we have secant, which is, at values of cosine x 1/2, cosine x equal to 1/2. Its inverse is secant, so we have 2, and they share the same values of x, which is pi over 3 or 60 degrees. So if you only have the sine, cosine, and tangent, just find its reciprocal so you can find its value. So for cosine x, for problem number 5, we have pi over 3, and we have 5 pi all over 3. So that's how we use our table of values if ever your table of values don't have the inverse function of the trig function. So for problem number 6, we have 4 cosecant squared x minus 8 equals 0. So we add 8 on both sides. So we have 4 cosecant squared x equals 8, and divide both sides by 4. So we have cosecant squared x equal to 8 divided by 4 is 2. And we take the square root of both sides. So we have cosecant x equals plus or minus square root of 2. So now we're going to be looking for the inverse of cosecant, which is 1 over cosecant x equals 1 over square root of 2 plus or minus. And the inverse of cosecant is going to be sine. So we have sine x equal to plus or minus square root of 2, which is square root of 2 all over 2. So we're going to be looking for all the values of our sine x. That's going to give us plus or minus square root of 2 all over 2, since it's the inverse of the function. So we'll have 4 values of this in our unit circle or table of values. So let's go ahead and find it. So sine x square root of 2 over 2 is pi over 4. And we'll have 3 pi over 4 and 7 pi over 4 and 5 pi over 4. So these are the values of our function for problem number 4. So we have, or for problem number 6, so we have all these as our values of our function. So now let's go ahead and answer problem number 6, problem number 7. So for problem number 7, we have secant squared x minus secant x minus 2 equal to 0. Now notice that we have a quadratic equation, and we can translate this into an algebraic equation. So most of the time, every time I have functions or trig functions as long as this, I change it into algebraic equations. I can easily solve it. So we have x squared minus x minus 2 as its translation, because we can equate x as secant x, and later on we're going to change it back to secant x after we evaluated this. So since this is a quadratic equation that's factorable, the factors of negative 2 that gives you negative 1 when you add them up would be positive, and negative 2 and 1 equals 0. So we have 1 times negative 2 is negative 2, 1 minus 2 is negative 1. So now we will return it or change it back to secant x. So we have secant x plus 1, and we have secant x minus 2. And by zero product property, we'll equate both of them to 0. So we can solve for secant. And secant x equals positive 2. So we're going to be looking for all the values of secant, which is equal to negative 1, and all the values of secant x, which is equal to 2. Now, we know that the inverse of secant x is sine. S is to c, c is to sine, so this is cosine x equals negative 1, and secant x is cosine x equals 1/2. So these are the two values that we could use. So using our table of values, finding all the values of our cosine x equal to negative 1, cosine x equal to negative 1 will have pi. So pi is over here, and there's only one negative 1 in our cosine value. And for cosine x equal to 1/2, cosine x equal to 1/2, we have pi over 3 and 5 pi over 3. So again, I'm just using this. You're not seeing it anymore, but I guess you already know how to use the table. So this is our problem number 7. And for problem number 8, it's another algebraic equation that we're going to modify. So we have 2 sine squared x plus 3 sine x plus 1 equals 0. We'll change it into 2x squared plus 3x plus 1 equal to 0. And now we will factor this out differently. So we have 2 times 1. Using the big X method, we'll have positive 2. And we need to find the positive or factors of 2 that gives you 3 when you add them up, which will give us positive 1 and positive 2. 1 times 2 is positive 2, and 1 plus 2 is equal to 3. So the second part is modifying the quadratic equation into 2x squared plus 1x plus 2x plus 1. And we're going to factor by grouping. So we'll have GCF of the first group is x. So we'll have 2x plus 1. And GCF of the second group is positive 1. So we'll only have 2x plus 1 in our equation. So now that we have a common factor, we'll have x plus 1 and 2x plus 1 as the factor of the quadratic equation, which we're going to translate into sine x plus 1 and 2 sine x plus 1. And just like what we did in our previous example, number 7, we'll equate it to 0. And we'll have sine x equals negative 1 and sine x equals negative 1 all over 2. So the x values that we have would be, using the unit circle, at sine x negative 1 and sine x equal to negative 1/2, it will be at 3 pi all over 2, 11 pi all over 6, and 7 pi all over 6. So these are the solution set of problem number 8. And for the last problem, we have number 9. We have square root of 3 cosecant x minus 2 equals 0. This one is a lot easier than the first two examples. All we need to do is to add 2 on both sides. So we have square root of 3 cosecant x equals 2, and divide by square root of 3. So we have cosecant x equals 2 all over square root of 3. And the inverse of cosecant, 1 over cosecant x, is square root of 3 over 2, and the inverse of that is going to be sine. Sine x is equal to square root of 3 all over 2. So all the x values that we're looking for would be at sine x square root of 3 over 2, and it's at pi over 3 and 2 pi all over 3. And this is how we solve trig equation using our table of values and sometimes our unit circle. So if you've learned something from this video, please like, share, and subscribe to my channel. Thank you.